that was awesome.
That was an entrance.
Good morning, night, evening, good time, everyone. I am David Fowler. I am a distinguished engineer on the .NET team. And you are?
I am Damian Edwards. I am a product manager architect on the .NET team.
Is that a real title?
It's a title I made up.
Yeah, makes sense.
Basically.
Awesome.
Welcome, everybody. Welcome, everybody, to Build. It's great to be back here in person talking to you about some thing that we really enjoy as a duo, like doing this type of stuff. We're going to talk about some performance stuff today in .NET. We're going to look at an ASP.NET app, and we're going to talk a little bit about native AOT work that we're doing in .NET 8 as well. Let's get straight into it. I want to start out by telling you that the first thing that you can do to get free performance in your ASP.NET or .NET applications is to upgrade your .NET version. Performance is a forever goal in .NET. What does that mean? It means every single release when we start our planning cycle, we go up to the whiteboard, virtual these days, and we put performance as the #1 thing, because developers and people who pay the bills like to see the perf numbers go up and the costs go down. Okay, so we do this every single release. That performance improvement comes from multiple places. It's not just the ASP.NET team. It's work in the compiler. It's work in the runtime. It's work in the JIT. It's work in all aspects of what makes up your ASP.NET Core applications. So here's an example. I created a new ASP.NET Core 3.1 application, Web API and Web Application. And then I just changed the TFM. I retargeted it to .NET 5, .NET 6, .NET 7, and then .NET 8 Preview 4, which is the current release that's out now. And you can see the free performance improvements I got by changing absolutely no code, but just changing those TFMs when I run some load against them. So if you are looking for a way to improve your performance, the first thing that we want you to do is to update the version of .NET that you're using. A little bit more on that. Some of you may have seen Stephen Tobe, who works on the .NET team, his epic blog posts he's been doing for the last 3, 4, I think it's maybe even 5 versions of .NET now, where he goes over, collects all the great performance improvements, and then does a huge blog post about them every year. I'm absolutely looking forward to the new one that will come out sometime toward the end of this year for .NET 8. The other thing that we've been doing for a while now is these Tech Empower Web Framework benchmarks. And there's the last 3 rounds of those benchmarks. I picked 2 specific benchmarks, and they're both running on ASP.NET Core MVC. I've got the JSON benchmark, and I've got the Fortunes benchmark, which actually talks to a database and renders HTML using Razor. And you can see that as we've gone from round 19 to round 20 to round 21, we have improved the performance of those benchmarks. That doesn't generally change the code in those benchmarks. It's the framework that's giving you all that benefit. Yeah, that free performance for upgrading. Come on, that's fantastic.
Free.
So today we're going to go a bit deeper on a specific application. So if you've heard of the eShop on Containers reference architecture application, we've taken one little piece of that, the catalog service, and we've called it eStore Lite. And then we have a sort of trimmed down front end, and we're going to focus on this eStore Lite and the front end a little bit and go through the process of optimizing that. So let's go ahead and do that now. And with that, we'll go over to David, and he's going to show us what we should do.
So we have no more slides, I think. It's mostly coding from here on out. Yay. All right, let's go. Live coding is fun. So I have a simple solution file called eStore Lite. It has 2 projects, a front end and a back end. The front end API is a Blazor server-side rendered application. That's new in .NET 8.
Right.
And the back end is a REST API that returns a bunch of catalogs and their images. So to see the application, let's just run this. Control F5, I'll run the application. And spawn the backend. This is the backend service. It has 3 endpoints, 1 to get all items by brand, 1 to get the image. All right. And then the front end, this is amazing UI. This would have taken me a few days back in the day before AI, but ChatGPT helped me put it in the middle of the screen. Then I had my coworker help me make it pretty.
So he's not even joking. He literally did all the CSS.
In Copilot, it was amazing.
And the help of David Pine.
So this doesn't really work, but it's a really cool page that shows you the things that you could be able to buy if it was a real store.
Right.
And I can actually go back and forth. So it's a very simple site. I can page. And I can't sort, and I can't buy, and I can't zoom in.
That's
it has really cool icons.
Trimmed it down for the purposes of focus for this demo.
Exactly. So my boss isn't here, but he told me we have to make it fast because customers are trying to use the app, and it's not working well in production.
OK, so that's a very good reason to make things faster. The other reason to try and make things faster in this land and world of cloud native, this age of cloud native, is that it often equates directly to cost. if you bought a server and put it in your own data center and you ran apps on it, often then, I worked in a company doing that many years ago, there would be plenty of capacity on that server, and it wasn't really a big deal if things were a little bit slower or used more resources. These days, you tend to pay for every CPU cycle.
Buy more cloud.
I mean, I could just buy more cloud. That's good for us. But these people want to save money with their apps. They want their apps to go faster. So.
Okay, what's the first thing you do when you want to make a thing go faster? Measure, profile, yeah, exactly.
Measure, profile.
Measure, profile.
Good answers.
You can do it in various ways. Most applications have like a dashboard with metrics, but we're going to do something lower level. We're going to look at the Visual Studio Profiler. I can look for Profiler. Does anyone use this in the product?
Lots of people use the profiling tools. I see a few nods, a few hands up.
Yeah, I see 6 hands. Can't see anyone, so don't judge me. Alt F2 is the way to bring it up in VS. And we're going to focus on 2 specific kinds of profiles, one for tracking allocations and one for tracking CPU usage.
OK, I see lots of other boxes
There's
here.
file I/O, async, counters, event, viewer, memory, and allocations look like the same.
Yeah, how do I know which one I should choose depending on what I want to do next?
Good question. So memory gives you a snapshot of the current state of the objects in your hierarchy.
OK.
And it tells you which things are linked in the object graph. Whereas allocation profile gives you everything that ever existed and where it came from.
OK, so
it's kind of a history of all the things that were ever made in your application.
I see.
And where they came from.
So if I did the memory usage one, I started the app, I gave it a bunch of load, and then I would be able to see when a GC occurs, I'm assuming, because that's when kind of the bookkeeping takes place.
Yep.
I would get a snapshot. I would get a report of the number of objects, what types they were, how much memory they were taking
Where
up,
they're stored.
where they're stored,
Yep.
and why they're being routed. Like, why are they still in memory? Why are they there?
Correct.
Whereas the object allocation tracking is literally every single time an object is allocated or moved around or whatever, it's like, we're going to keep track of that. And we get that for the entire duration of the
Exactly.
profile. Okay.
It's very expensive.
And it's very expensive.
So in the interest of time, I'll do 2 things. One is to get a baseline measurement of the requests per second. So this command line tool is Bombardier, and we use this tool internally. It's an open source tool on GitHub that anyone can use. And I'm going to point it to our front end, and I'm going to send 1,000 requests in total using 25 concurrent connections.
OK, so to be clear, this is just a standard load generation tool. There
Very
are many
simple.
load
There's a lot of
generation
these.
tools. We just happen to like this one.
There's a lot of them. This one works on both Windows and Linux. So I am going to, this site I believe is running in release mode, and I'm going to hit this with some load.
OK.
And I got like 50. So I am like plugged in.
Yes.
CPU and the client and server are on the same machine.
Right.
So they're competing for CPU.
Is that OK?
Yeah, for this demo.
For the purposes of this demo?
For sure, for sure.
So if you're doing this for real, often you will hear people say, separate load machine from your server, then do a separate machine again for your database or for your analyzer. We're doing this all on one machine today for the purposes of making this simple. And you'll see that you can still make improvements even if you're all sort of isolated in one thing, but you do hit limits when doing it all on one machine.
All right, so we got some baseline numbers. Let's call it 2,000, right? I don't know, something in the air, like 2,000. Yeah, 2,000.
OK.
All right, now we're going to look at
I'm going to write that down. 2,000 RPS.
That's like a...
So that I can check your performance as we go along.
Oh, no. So I have a pre-canned CPU profile in inches of time.
OK.
That is a baseline measure of the front-end application, right? And it's telling me that 96% of the time is spent in the kernel.
Well, we can't do anything then. We're done.
We're done.
Like, what are we supposed to do?
Talk
It's in the
over.
kernel.
Let's just go.
Who do we blame for that?
The team is working on improving the categories. Actually, while we were building this application, we found a couple of issues in the tool and in the product that I'll talk about eventually.
OK.
So the hot path is thread pool worker start. Not super helpful. Let's look for our own code.
OK.
So I'm going to open the details and change the current view to modules. Minimize this a little bit. And then search for front end. This is our code base. And get items async seems like a thing that we control.
So that's at the top of our code.
Top of our code.
That method, which makes sense because we ran load against that endpoint, which makes sense. Okay.
So the profiler ran, and it saw 758 samples of tracking the CPU in this method.
OK.
Let's see what that means. So we can view. Actually, I can double click. And it brings up a preview of the code, and where time was spent. Now, the CPU profiler does not handle async methods super well. So there's more time spent in here that you can't see. It's kind of spread out over the profile. But trust me, I know that most of the time is spent in this method. Right?
OK.
So we're getting a string from the back end, a JSON string, and then we're going to turn it into a catalog and the string goes away. And this is taking up a bunch of time, right? So this is one clue. Let's look here.
So is that like literally nearly 4% of the entire
thing is this
was getting that from the back end, storing it in that string called response, and then we immediately turn that string into a catalog, and we never use that string again.
This is the definition of garbage. Right?
Isn't that just what web programming is? It's just
temporary.
Strings going back and forth?
Strings and just garbage.
Okay.
Exactly.
Strings and garbage
Strings
is
and
web
garbage.
programming
To
101.
collect the garbage, we need garbage in the first place.
Okay.
All right, perfect. So that's the CPU profile. I want to show you one more interesting view that's kind of cool. The caller-callee view. So you think about a single call, there can be multiple ways you end up getting to a method. There's the call tree where you can see a single path, and the call graph here shows you all of the callers and all the things that are being called by this method. So this is a nice view that shows you where all the 13% of this call is accounted for. So I can see every call path from my callers through me to my callees. Right?
Okay, so this is like the middle is always the focus that we're currently looking at.
Right.
The right-hand side is what that calls, and it gives us a nice color coding of the most expensive things we're calling.
Top to bottom.
And the left-hand side was what you were saying, is what's coming in.
Yep.
How did I get to this middle function?
Exactly.
And I can navigate through this to kind of explore, right?
Yep. Super interesting. OK, this is one profile. Let's look at the other kind of profile now, the memory profile.
Okay.
So I have here an allocation profile of the same application, 1,000 requests at a time. We want to get the requests. We want to send a bunch of requests up front to warm the profile.
Yep.
We don't want to capture one-off allocations that happen once per process. That might be big.
Yep.
So I will narrow the time down to be a specific category of requests. And I'll look at allocations. And it will show me, the tooling will show me the allocations all made in this time frame. Nice, like minimized. Oh. I open the UVS. I want to see the number of bytes. I want to see average bytes. Perfect. All right, so first off the bat, it's showing me that we're somehow allocating 200 megs for 1,000 requests. And they all happen to be this 65 kilobyte byte array.
Byte arrays.
And it's coming from a memory stream constructor.
Okay.
So I can look at the backtrace and figure out where it's coming from. So somewhere in my application, the HTTP content is showing me that we're allocating a giant stream. Right?
Okay. Okay.
And if you go far enough to the end of time, you can see where it comes from, right? It's deeper and deeper and deeper.
Goodness me, we don't have a big enough monitor, Fowler.
Yeah. So,
there we go.
But trust me, I know where it's coming from. This is my app. I wrote it. All right, so we got 2 clues.
2 clues. Lots of bytes.
Lots of bytes.
And
that call to allocate a string. So here we have another thing, right? Here's the strings. So bytes and strings are always the issue. Strings are the worst. Is it going to show up? Is it too many strings?
it could be too many strings for the tool. I mean, I can see there's 224,000 of them. That looks like a lot.
Is that?
Oh, there we go.
Oh, yay. It loaded. OK, perfect. So the first thing we're going to look at is the get UTF-8 string. And it's coming from HTTP client. That call we saw before, getting a string from the back end, turning it into a string, and then turning that string into a catalog, being thrown away. It's allocating, how much memory? 28 megs? This is like 10 megs, I think. 14 megs of
14
strings.
megabytes in that, just that string
Just
part.
that string to be just a bunch of garbage.
Okay, so again, just to reiterate, your HTTP client call is calling your backend API. It gets back bytes. Ultimately, everything is going to come back as bytes. And I can, that's why we've seen some bytes and stuff in there. And it's also why this method is like, we'll read this buffer, and the buffer is bytes, and then turn that into a string,
yep.
just so that we can then turn around and turn that string into a catalog object. So we're like, well, why do we have to create
all this
string?
waste happening in between, right?
Okay.
So let's fix it. Let's go back to our application and go into our catalog service. That seems to be where the problems are.
So is this where we expect to see horrible code? That code looks normal. That doesn't look
This code
that terrible.
looks pretty OK.
Right.
Not terrible. I wouldn't have done this way. I wouldn't have done this. But
Okay. What would you have done?
I would have used the built-in methods.
You just told us this was your application.
I know.
Okay.
The guilt is here. I felt bad typing this.
It was past Fowler who wrote this, not current Fowler.
So the first thing you want to do is use the built-in methods to get directly from the actual endpoint to JSON. And there's 2 of these. There's one if you want to get the response first to check the status code, and then you can turn that into JSON. Or you can just directly go from client to JSON payload. And that does the most efficient thing, which is buffer to a stream, and then have the stream pass to the JSON serializer directly. So there's no grabbing the entire content of the body in one go
Okay.
to be turned into something else.
Okay, so instead of filling my bucket and then converting that bucket into a different format and
Yep.
then having that bucket turn into the thing I want, I can kind of do it bit by bit, and I mean a much smaller
Exactly.
bucket. Okay.
Incrementally and asynchronously. So I am going to just do this and return this. Creating a new JSON options every single time is really, really, really bad. We actually had a lot of internal teams do this, and it showed up in our profile. We have a profiler internally that tracks the profiles of all services. So if you're bored, you can go look and see what is the top CPU profile in like the company. And this is one of them, having people new up these objects every single time because they were used internally for caching. The caching was being like thrown away every time you create a new one. It was so common that we had to add a cache in .NET 8, I believe, to the JSON call to make this be more efficient.
Wow.
But it's a limited cache, so you don't want to have this pattern. You want to extract the options to be a field or be shared.
We added a call to allow for this call. We added code in the framework to allow for this call pattern because it was so common.
It was so common.
Just to try and alleviate the problem slightly, but there's only so far.
Yep.
Okay, so the best thing is like don't allocate it every time.
Put a Band-Aid on the thing. You see this? I don't have to type. It's just typing for me. It's amazing. This is how I code now. I just copy and paste and prompt. All right, so let me get rid of this, and
Okay.
we will pass this in.
So I'm just creating one instance of it.
And this class is a singleton.
Okay, so I don't have to make it static or anything.
I
I know there's only
I
one.
should make it
You
static.
may as well make it static, right?
Out of paranoia.
Okay.
And then, boom, no async. Oh, no state machine.
Oh,
All right,
interesting. Okay.
more perf. That's one thing that we optimized. And then the second thing we're going to optimize is the image endpoint. The image endpoint is doing the same thing. The catalog service gets the image by ID, gets the response, and then if it's a 404, return not found. Otherwise, read as byte array async.
Oh, so that's where all those bytes were coming from.
Yeah.
Right, okay.
So we have to buffer the entire response, and then we have to return a byte array that you can mutate for yourself.
Okay.
So we read the entire thing into an array, and then to return a new array, we copy that into a memory stream that you get back.
I see.
It is like double the pain.
It's double the allocation.
Double the pain.
Not only does the framework have to have enough bytes to read it from the endpoint, we then have to create another pool of bytes or another object
to give back.
to you to hand back.
Right.
And there may even be more allocations in the process of doing that because it doesn't know how many bytes are going to come back.
Exactly.
So it might start out with an array of a kilobyte, and that gets full.
And it
And it
grows.
goes, oh no, let me create an array of 2 kilobytes, copy the 1 kilobyte to that the 2 kilobyte array, throw that one out, get more, and then it goes, I run out again. Let me create 4 kilobyte one. And so like there's all these allocations going on under the covers. Now, we do things in the framework to make that as efficient as we can, pooling and whatnot, but ultimately we then turn around and just give you a new one which has exactly the amount in it. So
Exactly. So you want to use streams. If you're dealing with big bodies, you want to use streams and do streaming operations.
Okay.
So for the most part, I could change this from read as byte array async to read as stream async. But I'm only proxying the response body. I want to proxy the entire request, the headers, everything that comes from the back end, proxy it as a pass-through to the front end, right? So I can use our beautiful reverse proxy called YARP. Does anyone here use YARP?
I see some hands, people using YARP. Excellent.
So I have a reference to YARP 2.0 in my project. 2.0 came out recently.
Okay.
And I can just, there's a new method actually was added by a contributor. I can do add HTTP forwarder. Oh. Nope. Add HTTP forwarder.
There we go.
And I can use this new helper method, map forwarder. I can paste in the old image link. I need this URL, so I have to copy and paste this out of here
Okay.
to this destination. And the target endpoint is API v1 catalog items. Who made this thing? Oh, I did.
This is what API URLs look like, right?
All right, so this proxies the front-end URL to the back-end with this URL. Pretty simple, right? And that should just pass through the bytes like a pipe, going from back-end to front-end. Just
So we basically just connect the hoses
Yeah.
rather than like use the bucket analogy again, fill one bucket and then pour it into the other hose
Exactly.
and have to figure out what to do with the bucket.
it's a real-time pipe.
Okay.
So it's still working, so we didn't get fired. Perfect. We didn't break the app on the path to making it faster.
Okay.
So the last part, I guess, is to do a profile to verify that we actually did something useful.
Okay.
Let's do
Prove
an
it.
allocation profile. And it seems to be working. and I have a million consoles open. Let's hit that endpoint, let's make it warm. Then again, then images. And you want to make sure that the app actually works. Because I think we tried it a couple times, and we saw like 400, and we were like, oh, it's so fast, because it was doing nothing. It was the wrong endpoint, it was the wrong place, and we were like, oh, it's not fast.
It was throwing exceptions.
It's a 404. It's a fast 404. It's not really a real thing. All right, stop collection. And we're thinking about the profile, thinking about allocations. There should be a lot less now, right?
You're thinking, what a good job we've done.
Yeah, it should be like, man, you guys did a good job. Knocking the perf down.
All right.
All right. And allocations. You can do it.
Come on.
It's on stage.
Show us. There we go.
Have to do it. Perfect. Remember the first rule, zoom into an area of interest. So let's pick this subset of allocations. You know, I do not see byte arrays. I do see strings. Let's look at the numbers, though.
OK.
3 megs.
That's a lot less.
So it went from 20-something megs to 3 megs, and then the byte arrays are just gone. Right?
Perfect.
Funny story. During this prep for the talk, we found this was happening. Like, why is Blazor allocating like a crap load?
27 megabytes.
Right. And we sent email to the team, and this happened this morning.
PR to fix that issue. So this is the other thing about doing performance profiling, is that you might end up finding opportunities in areas that you weren't specifically looking for.
That's so nice way to put it.
Oh, that isn't even the thing I was testing, but OK, we can fix that too. That's great. All right, so we did the front end. Shall we look at the back end now?
Are we on time? Are we good?
No.
Damn it.
We are good, but we're doing, we have plenty of time. You're doing well, actually.
OK, back end. OK. The back end, who here is a back end dev?
Who builds APIs? Oh, lots of hands. Excellent.
Don't judge a friend. I'm full stack. Let's go. I did this whole full stack app.
You did?
Yeah.
With the help of AI.
Yes. And coworkers.
And now we have our AI quota for this talk. Done.
All right, so the backend is pretty simple. The backend just has one controller with 3 endpoints. It had to, but Damian made it over and added 3 endpoints.
I did, sorry.
Thanks. Very simple, getting the items from a Postgres DB using EF, doing paging and ordering, and then the image endpoint grabs the image, grabs the ID from the database, and then figures out which picture it should return based on that ID. Right.
Pretty straightforward. We've all written code like this for decades, really, now.
And I will show you another pre-canned profile because we are not going to run out of time. And it also says kernel is 45%, but database is 48%.
I see a new color in the graph. Yeah, that's...
We got a category that is pretty good.
Interesting.
Awesome. So it turns out the database is the bottleneck in this app, and it makes sense because all we're doing is calling the DB from the endpoints.
OK.
Right. Let's find our code again. So we're going to narrow down to one area to avoid startup costs.
OK.
And we're going to open details and look for modules. Let's find our assembly. Where is it? Catalog service.
Catalog service. There it is.
And items by brand ID async is taking up 48%. And this other one is taking up, like, I'm going to ignore it for now. You didn't see me. Oh.
Well, interestingly, right above it,
Same method, right?
Entity Framework Core, which is obviously database in this one, it's saying 65% basically of our inclusive time is spent in our calls through to our database.
Doing stuff.
So that probably looks like a good candidate to go and see if we can improve.
So let's do we want to see any of the call tree? So let's look at this a little bit. So this is one path to this method, right? And we're looking at the things like how much does this cost? Turns out getting the DB set is 14% of the 25.
Wow.
Just accessing the DB set.
That's the property on my DB
How is that
context.
possible? OK, well, this one is 13%. Getting the DB context dependencies, this is super expensive. So every request comes in, we get the DB set, and then it just costs 14%. Apparently.
So this just looks like overhead of getting my DB context, accessing the property. It does some late initialization happens before I even run my query.
Yeah.
OK.
Yeah. OK, and then there's, I guess, other things in here that are EF-centric. That is the big one, though. That is the biggest thing.
That is the big one. So can we fix that? How do we fix that?
We can. We should. We didn't get a baseline, though, of the back end.
Should we do that?
Get a baseline?
OK.
We should get a baseline.
Let's get an RPS.
I have this very convenient back end tab. You can name tabs now in
Terminal.
It's super nice.
Just don't close it, because you lose them. Then you have to rename them all again.
This was open for 3 days. All right. App is running. App is not running. App is not running. Let me verify the app is running. This is the CPU profile. This is the app. Let me set the startup project to this thing.
Okay.
I'm going to run
the app.
the app.
We should see our Swagger page come up.
All right,
Excellent.
there we go. Open API page. Damian.
It says Swagger right there,
Swagger
David.
UI. Pedantic.
All right, see lots of 200s. You're hitting it with a fixed number of requests, yeah?
Oh, yeah.
1,000 every time?
Should I crank it up? Should I make it higher?
Sure. Hit it with
10,000
10,000 requests.
Yeah. All right.
We haven't got time for that. What did you do that for? Okay, there we go.
Pretty fast.
2,800 requests per second? I'm going to write that down.
I feel like I'm being graded.
Well, your performance review is coming up. It's that time of year, so.
I like this. OK, so we should make it faster.
Let's make it faster.
So we should go to the docs, right? The docs will tell us how to make it faster. The docs on EF just tell us, like, do these things.
Do these things.
And it'll be faster.
OK.
All right,
let's do all the things.
Let's do that then. There's a big document here on efficient querying and different techniques for indexes. And you paid the DBA more money, and then you make it faster.
Let's assume for the purposes of this talk, the DBA has already been paid, has optimized the database, and the problem is in our code.
All right, so the first thing you want to do is, I think, we want to turn off tracking of objects.
OK.
Right? So if you think about how an ORM has to work, in EF, you can actually do a query on a bunch of objects, get them back, change properties, call save changes, and somehow EF knows that the things that I change were changed. How would it know that? It has to track every single object returned from a query, just in case you might change them.
OK.
Right? That's super useful when you're in a stateful application like WPF.
Or if you're doing an update where you get it first.
Yeah,
and then,
get to then change. When you're doing read-only queries, like, it's not super useful.
OK.
So for the most part, in ASP.NET Core APIs that are read-only, you can turn off tracking on a per query basis.
OK.
Or you can do it per app.
Per app if you want to.
Or
per context configuration.
Yep.
So what do we do? What else do we do? How can we make this?
The other thing that we want to do is we want to do this thing called key set paging, which we learned about as part of this talk prep.
OK.
So paging, normally, we're doing things like skip and take, which on some databases cause a table scan.
OK. Depending on your schema.
Depending on the schema, depending on the database.
OK.
So the idea is that you want to do paging based on an index column.
OK.
Right. So I'm going to use this helper here that I have, get catalog items async. But I have to change how this is called first. So instead of paging with a page size and a page index, I'm going to page with an ID. I'm going to say, give me all things before this ID or after this ID.
And it could be any column.
It could be any column.
We're just using the idea. It could be the title, it could be
the
a category, it could be whatever makes sense for the data that you're paging through. As long as that column is indexed.
Yeah,
otherwise,
make sure it's indexed.
OK, so this kind of changes the mechanics of how we're going to
This changes the caller, so we're going to break the front end now.
OK, that's fine. We're only looking at the back end at the moment.
That's not
all
nice.
good.
The devs are going to be angry. So we've got before, after. And this has to be preserved to this call, keeping the page size, before, after.
OK.
Then we're calling before, after here. And then the query is get the catalog ID, get the before, after, and page size.
OK.
And this should replace all this stuff. I did make one change where I'm not getting the total count for all the rows. I just have a next previous button. There's no like page X of N.
OK.
It's one of the big changes.
I mean, you could add that if you wanted.
I could add that.
Right.
So what does this do? It's a very simple query. It turns off tracking, and it orders by the column I'm trying to do paging on. And then this is a normal filter based on the brand, if there is a brand. And then this is the part where paging happens. So I'm going to pass an ID from the client side that says, give me all items after this ID, or give me all before this ID.
OK, right. So basically it turns the skip into a where clause.
Exactly.
OK.
Which is more optimized on
Which is more
databases.
efficient.
And then we grab more than one of the page size so we can tell if we're on the last page or not.
I see. So we get one more row than we actually need just to know if there's another page or not.
Yep. And I wrote this code on Twitter, and it made people super angry, so I'm going to do it again in this talk. So first ID, next ID. And there's an easy way to do this, but to show you C#, 12. Right? That's 12 now. How do I get 9? I want to return the paging information on the front end needs to know if there's going to be a previous page, the next page.
Okay.
It needs to know the bounds of my pages, right? So to go to the next page, I need the ID that is in the next 10. Let's say
first
we go
ID
from
in the
0,
next page.
exactly.
OK.
You got it.
And then the previous page needs the first ID of the previous page.
You got it.
OK.
All right, so first we're going to do a list pattern and say if this is empty, we're going to return 0 and 0, which is never going to happen, hopefully. If there's one item, we're going to return no Copilot. What are you doing? The only one.
Okay.
ID. And then if you have more than one, give me the first. First dot last. So give me first dot. Look at that. You almost got it. I'll pass. I need to change this structure a little bit. I have a new model here. Look at that. I was prepared for this talk.
All right, nice. So again, we're just changing from the
last
properties.
ID,
Yep.
last page, and data. Okay, so first ID, last ID, next ID. Call it next ID. And then this one is, so if we're on the last page, we should get back less than what we asked for, right?
Right.
Page size.
Because we asked for that one extra.
What do you call it? Oh, that's right. Okay,
That's right, yep.
And then just take page size.
And then we do that actual take down there. And that's to trim off that extra one if it happens to be there.
That's right.
Right, okay.
Okay. One of the things that happens when you write this query in EF is EF has to take this query, turn it into SQL. So it has to walk all the expressions, extract the values, turn them into parameters, and then turn that into SQL. That happens every single time
Sounds expensive.
you do this, right?
Okay.
It can be. It can be.
I mean, it's actually surprisingly fast at what it does.
It's pretty efficient.
But we can make it faster.
Yeah, so you can avoid all that if you pre-cache that work to happen all up front once.
Okay.
Right? If you think about how you write a query in SQL, you add the app parameters, and the string can be cached like for
It's a constant.
as a constant.
It doesn't change, right?
Right. It's the same constant, different values. The same thing in EF is using a compile query.
Okay.
So we can use a compile query instead that takes that exact query that we had before and puts it in line and wrapped in this compile async query. Right?
So it basically generates a method for us. It does all the hard work up front, generates a delegate, and then we just call that delegate.
Okay. Exactly. So my call is the same query here before, and we call it from a method. That's a helper.
Yep.
And then we get the data.
Okay.
Same value. So I just have a helper that we have in the backend. We'll just call it get catalog items. I hope it still works. Compile this thing.
Totally going to work.
All right. We're almost
So
done.
we remove tracking, we moved to key set paging from offset paging, and we are now using compile queries.
Yep.
Anything else?
Yeah. So a couple more things. One of the big things we saw was accessing the set was super expensive.
Right, that DB context stuff.
Yeah. So there's a really nice feature in EF called DB context pooling that you can use to just like pool the DB context.
Wait, that's it? You just have to do that?
Done.
Okay, that sounds like...
How we get paid more money.
Okay.
So add this to your code, impress your boss.
Nice. Anything else before we run it again?
Yeah, there's like, this is live dangerously, right?
Live dangerously? There's a live dangerously method?
Yeah.
Okay.
So there's thread safety checks.
Ooh, we don't need those.
Who needs those?
Now, to be clear, the reason we don't need those is because we know in this app we're not sharing DB contexts across requests.
I hope.
Like, hopefully. We shouldn't be doing that.
It'll be fine.
But we're using DI, and it's scoped and all the stuff, so it should be fine, right?
The last thing we can do, optimize the model.
Okay.
All right, so when you write an EF DB context, you write it with these things, right? To describe the table, describe how things map from objects to the tables. EF has to read this and then map this to the actual objects in memory. So it has this state tracking all the objects and how they map from the database to the actual objects, right?
Okay.
That happens at runtime, at startup.
Okay.
If you want to avoid that, what you can do is use one of my mini console window open, and this I can run this thing. .NET EF DB context optimize.
Okay. And that generates code?
Optimizes stuff.
It optimizes stuff. It doesn't optimize my database. Like it generates code that I can then use in my app. Okay.
Exactly. So
I would have to redo this when?
Whenever your model changes.
Whenever my entity model.
Yep.
Okay.
So I'm going to run this, and it's going to read my application, read the model. It's going to succeed, and then tell me to call
a
this.
method. Okay.
I can just copy it. This is super nice. I can just copy and paste this. I want to be in.
So we do this in startup, where we're configuring our database configuration. Here we go.
Right here, and we can just do this.
You
All right.
see a column missing?
Oh, I am. Oh, this should add that to the.
All right, so let's see if the app still works after all those optimizations
I don't
that
want
you
to do
just
it.
made.
Let's just assume it works. Move on.
What's that?
Let's just hope it works and move on.
Okay. No, I want to see the numbers.
You want to see a perf
I
run?
wrote down the numbers.
Do we do a perf test to make sure it works afterwards?
How do you know that it worked?
Because we're on stage in the middle. They just believe us.
All right, so not the front end.
Hold
We're
on,
only running the
this is
back end.
The back
right?
end. The back end is running.
Okay, so just go back to
F5
your
works.
command line, and we'll see what we get.
Oh, are you nervous?
No. Warm up.
It's a big one.
That was a warm up. Oh, I see number went up. So what is it now? 5,389. It was 2,800. So you've basically doubled the
We're
performance.
gonna get paid double.
Hey, that's not too bad. All right.
You get paid double?
Do you get paid double? No. You can have an extra Monday off. Well done. All right, so with that, we're going to switch focus to native AOT. So I'm going to flip over to this terminal here. I want to preface this by saying native AOT is very new for ASP.NET Core. It is new in ASP.NET Core 8, and it is absolutely not for everybody at this stage. It is not something you can apply to every application. It does not work in your Razor applications. It doesn't work on your MVC applications, and it doesn't work on your EF applications. So we just showed you a whole bunch of things about how to optimize the performance of EF and some other stuff in the application, and now I'm going to tell you that we've switched to a branch. Well, I have to switch to that branch, actually. Where none of that stuff is actually, can you like get clean up your mess, man.
Oh man. Let me just make sure.
Where we've actually moved the application to use technologies in ASP.NET Core that are actually compatible with native AOT. And what does that mean in ASP.NET Core 8? And Fowler is right. Yet some of those things that don't work, they don't work yet. In ASP.NET Core 8, for APIs, you'll be able to use the minimal API style of APIs that we introduced in .NET 6. But we do not have EF support yet. We do have database driver support. So ADO.NET works, so you can do raw SQL, and there is a skinny library that I've created called Nanorm, or a Nano ORM, that gives you like a Dapper-like. Who's used Dapper, like the database access? Yeah, lots of people, okay? Kind of that type of style. So if we go back and look at your code now, that I've just completely changed because we changed branches, right? And so if I go over here and we look at, we've got this catalog API now. So this is effectively the same code that we had before, except now, rather than using MVC, we're using minimal APIs. Right? And this was a fairly simple API, so that was a fairly trivial change. The other thing is minimal APIs is quite a lot faster than MVC because it does a lot less. MVC is very flexible, it's very powerful. It gives you a lot of capabilities to hook in to the way MVC finds controllers, creates controllers, finds the action, invokes the action through a filter pipeline. Look at the results. All that stuff is extensible. I didn't even mention model binding. Like model binding, validation, formatters, all of that functionality costs time. It costs compute. And the architecture of MVC is great, and we know a lot of people really enjoy it. The minimal stuff allows you to do lots of very similar things, but it does it in a minimal way. And we've changed a lot of the architecture under the covers so that it just does less if you're not using particular features. So it does end up being quite a lot faster for these types of situations. So that's what we've got here. The other thing is that I mentioned we're not using EF in here anymore, even though there is a DB context. We have in this model class, we have a bunch of methods that are just using SQL. Okay, so again, a lot of people put their hands up saying they use Dapper, so I know a lot of people do this in their applications today. And so I've got down here, here's my data source. I say query async. I want to get some catalog items, and then I pass in some database parameters, which will get filled into my SQL query up here. Very, very simple stuff, the type of stuff you've seen before. The advantage of doing that in this situation is that this is now compatible with native AOT. And so if I go back to my terminal, and I make sure I'm in the right spot. I'm not. I'm in the artifacts folder. OK, so I can now go to this, and I can .NET publish this. And because I know I have marked this project as please publish native AOT, we're going to see a couple of other things happen down here. So it first builds the project, and then it says generating native code. It runs it through extra compilation. So the C# compiler and the MS build targets produced IL assemblies, and now we're going to compile the IL ahead of time, hence AOT. So rather than there being a JIT or just-in-time compiler that takes your IL at runtime and then converts it into machine code that your CPU can run, we do that ahead of time. Okay, so now I have a native executable. Where's that native executable? I'm going to actually run that again, and I'm just going to output it to a different spot so that I know where it is. Actually, you know what? I know where it is. So it's right there. Let's have a look. I've actually got this artifacts folder where I put it previously. I'm going to go back up here. I've got my artifacts. We're going to have a look inside there. There's the catalog service AOT, and we're going to look inside there. All right, so there's my catalog service.exe. There's not a lot of files in here. So the other thing that happens with a native AOT is we automatically deploy single file. There is a runtime in your executable. Okay, so this is self-contained, single file, no JIT, native AOT compiled. You'll also note this is less than 17 megabytes for everything that we just saw. That includes MPG-SQL, it includes my little nano ORM, it includes ASP.NET Core, it includes .NET itself. It's all being compiled down into this 16-point-something megabyte executable file. If I were to try and do that with the other project before I made it AOT, it would be a lot bigger than that. How big would it be? Be about 90 to 110 megabytes. Okay? So this is something that the other benefit of native AOT is you end up with very, very, very small files. So if I run this now, ooh, wow, that was quick.
Is that a trick?
Wait, okay, so a couple of benefits. We saw that the file is very small, but we saw it started up really quick. But how quick? Well, I want to show you how quick. So actually, I'm going to stay in here.
Was it on before? Did you cheat?
What's that?
Did you cheat?
Did I cheat what?
I don't know.
No.
That was fast.
It was very fast. I'm going to go back into my artifacts folder. I wrote a little harness here, a start timer. Why did it do that? Oh, because I'm in artifacts. And I'm going to, this little harness app starts my exe, waits for it to be ready to receive requests, then it sends a request to it, and then it shuts it down. And then it times that whole thing. So if I do that right now, okay, and I do that a couple times, because you like to get things warm. Okay, so this one, I'm in the non-AOT'd one right now. I'm in catalog service. So without AOT, you can see it's taking what? Started after 16 milliseconds. That's what the process said I have started. That's the OS level. Wasn't ready to receive requests for a second. I'm just joking. A second. And then the first request was after 1.2. If I go out of that now and I go back to the AOT version, and I do the exact same thing I did a second ago, but I do it on the AOT. Okay, I couldn't even finish talking. Okay, so this time, 16 milliseconds for the processor start, that's the OS level, 55 milliseconds. It was a second before. Now it's 55 milliseconds. So then I ran the first request, and then 188 milliseconds, the app had finished responding to the first request. What was it before? 1.2 seconds, 1,200. This is the primary benefit of native AOT. If you have situations where the cost and the time that you wait for the application to start is critical, cold start situations in microservice deployment, pods going up and down, you need that new one to come up as fast as possible, this is the technology that you might want to take a look at. Okay? There, it's nice. So we're only at preview 4. This is using the preview 4 bits. We're continuing to work on this in ASP.NET, in .NET 8, and you will see, hopefully, these metrics improve as you go along. So let's go back to the slides to close out. Thank you. So the calls to action of what you've seen today. Update to the latest .NET versions, all right? That's where you should start in order to get your performance benefits. Learn how to use the analysis tools. We saw David spend a lot of time teaching us how to use the Visual Studio Profiler. There are other analysis tools as well. There's Purview, command line tools like .NET Trace that you can use to take a trace on your Linux machine and then analyze it on your Windows machine to find those opportunities. Second, consider alternate approaches to your code to get better performance when the trade-offs make sense. I just talked about native AOT. We talked about some of the EF things. Some of those things have a different cost, though, sometimes. So you might get more performance, but you pay for it somewhere else. Maybe it's a little harder to maintain. Maybe it's more code. Maybe you don't get as good a throughput on one thing versus another, or worse startup on one, or more memory use. There are always trade-offs in this game. Minimal APIs can be faster than MVC, so take a look at that if you're interested in performance. And consider database technologies like Dapper and ADO.NET for those really, really critical pages and APIs where you need to get the database access to be as fast as possible. And then lastly, for native AOT, consider native AOT where it makes sense. Okay, given all the caveats that I just talked about, have a look at that if you think that makes sense for what you are going to do. There's a QR code you can see here in order to learn more about what we talked about today. But thank you all for coming. I will be available in the experts area afterwards, and have a great build.